Okay, so example 3 here is also inequality is a combined function. And example 3 asks to solve the following inequality where sine of x is greater than the logarithmic function, so log of x. And here again, I have two different families of functions. One of my functions is a trig function. It's a trig function, and the other one is a logarithmic function. So since I have two different families of functions, one of the ways for me to actually solve this is to graph both of them and to figure out where sine of x is actually going to be greater than log of x. So I'm going to go ahead and just graph the functions. Since I have a restriction on my logarithmic function where x has to be greater than 0 and there is a vertical asymptote here, I'm just going to stick to the positive x-axis when I'm graphing this function, even though sine of x is defined for all values of x. I'm going to start off by graphing sine of x first. Okay, and sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, 3 pi over 2 is negative 1, and sine of 2 pi is 0. Okay, and I'm going to go ahead and graph log of x, and log of x has a vertical asymptote of equals to 0, so I'm just going to draw my vertical asymptote. And one of the key points for a log of x function is that log of 1 is equal to 0, and I have to figure out where 1 is on the x-axis. Pi is 3.14, so if I write 3.14, pi over 2 is approximately, I'm just going to put that into my calculator, so I'm going to figure out half of 3.14 is from 1.57. So this is 1.57. So if I'm looking at 1, it's just going to be approximately right there. So that's where 1 will be. So that's one of the key points for a logarithmic function. I'm going to go ahead and graph my log function. Okay, so that's y equal to log of x. And the question here is, where is sine of x greater than log of x? So if I look into just the first half, or I would say the first quarter of the function, sine of x is greater here until it touches this point. So, and 0 is not included because of the fact that I have an asymptote here. So sine of x function is greater than logarithmic function from 0 to that point right there, and I have to figure out what that point is. So it's got to be between 1.57 and 3.14, and I'm just going to approximate that to around 2.2 or 2.3. So it's going to be between, so sine of x is greater than log of x when x is an element of between 0 to, I'm going to say around 2.3. And again, you have to approximate it here because you're not 100% sure, so you're just estimating. And I'm just going to show you, I have a graphing calculator here. I'm just going to show you what that value is and if we're close or not. So I'm going to go ahead and graph it on my graphing calculator. You can see the shadow there. So I'm trying to put a shadow. There we go. Okay, so I'm going to graph my function. So I have sine of x first, and the second one is going to be log of x. And just going to go to my windows to see if that's good. And that's what the function would look like. That's sine of x, and I got the log of x function right there. Okay, so I'm just going to trace this to figure out that point of intersection right there. So I'm just going to press trace. And you can see the values at the bottom of what point I'm actually tracing. So I'm just going to scroll down. Oops, sorry. Scroll down to that point right there. It's approximately 2.67. So I was a little bit off. It's 2.3, and again, I was doing this by freehand, so I just had to just estimate it here. But the precise answer would be around 2.6736959. That's basically so close to that. I wouldn't say it's precise. It's close to that. It's an estimate, unless I figure out the point of intersection there. All right, and that's it for this example. And just let you know what your homework is going to be. And that's it for the lesson, sorry. The assigned homework, you are to go through page 457 to 460 and answer communication question 2, 3 to 9, 13, 14, 16, as well as 17. And now I just want to congratulate all you guys. You've learned everything you need to know for this advanced functions course, and hope you guys do really well on this test.